In this session, we're going to see quadratic functions, and we're going to find out what the vertex formula is, where it comes from, and how we're going to use it. Remember that a quadratic function is a function of the form f of x is equal to ax squared plus bx plus c. And in the past, what we did was we completed the square on x and ended up with hk, which gave us our vertex. We're going to find out a different way to do the same thing. Remember that when we completed the square on x, we factored the leading coefficient out of only the terms that had x. So I'm going to factor an a out of ax squared plus bx, and that's going to leave me with a times x squared plus b over a x, and then I'm going to close the parentheses, leaving a space in there, plus c. The reason it's b over ax, remember, is that factoring looks a lot like division. We can check this by multiplying. If we were to distribute the a, we'd end up with ax squared, and then the a would divide out. When we do complete the square, now inside the parentheses we have a lead coefficient of 1. We look at the linear coefficient b over a. You may recall we take half of that coefficient, so half of b over a, which in this case is b over 2a, and then we take that number and square it. And so for this generic thing we get b squared over 4a squared. That's what we add inside the parentheses to complete the square on x, but then remember we would consider, what did we really add? We really added b squared over 4a, because when we distribute that a, one of the factors of a divides out. How do we offset adding b squared over 4a? We subtract b squared over 4a, and now we've ultimately added 0. Let me clear away the computations we just had and rewrite what we have. We now have f of x is equal to a times the quantity of x plus b over 2a squared. Just review your completing the square stuff, if that was a little obscure. Plus c minus b squared over 4a, which I'm not really going to deal with because my focus is on what's inside the parentheses. Recall we had expressions that looked like a times the quantity of x minus h squared plus k, which means that the number inside the parentheses is associated with the x-coordinate of the vertex. So now we can consider the vertex, which is going to be negative b over 2a for the x-coordinate, and the reason for that is we changed the sign on what's inside the parentheses. Now let's go back to function stuff. Given an x, I can find out y by putting a value into the function, right? So if I put negative b over 2a into a function that's called f, the output is f of negative b over 2a. That's going to be the y-coordinate of the vertex. So the vertex is negative b over 2a, comma, f of negative b over 2a. And this is what is known as the vertex formula. Now, just in case that little voice in your head is wanting to revolt, I don't want to memorize something new. If we remember our quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This negative b over 2a actually shows up in part of the quadratic formula. So maybe that will help us to remember the vertex formula. Now let's see how we can use it. We're given a function f of x equals negative x squared minus 2x minus 6, and we're asked to identify the vertex, axis of symmetry, intercepts, and range, and then sketch the graph of the function. These are the same things we've been asked for before. We're just going to do so in a slightly different fashion. So for the vertex, I'm going to use the formula. We're going to look at negative b over 2a. In this case, what we have is that a is equal to negative 1, the leading coefficient, the one on x squared, and b is equal to negative 2. When I put those into the negative b over 2a expression, it's the negative of negative 2 over 2 times negative 1, just substituting for those values of a and b. Simplifying will give us that this answer turns out to be negative 1. That's the x value of the vertex. What I now need is the y value of the vertex, which is going to be achieved by evaluating the function at negative 1, which I'm sure you can verify is equal to negative 5. Hence, the vertex is at negative 1, negative 5. Now, because the lead coefficient was negative 1, I know that this parabola opens down. Since that's the case, I now know the range of the parabola. The range is going to be negative infinity to negative 5. And that also indicates a maximum value for the parabola. Oh, I forgot a comma. The maximum value of the parabola is negative 5. Some parabolas have a maximum, some of them have a minimum. We're going to see about that in a future example in this session. We were also asked for the axis of symmetry, and as you recall, the axis of symmetry is a vertical line and so has equation x equals, and then we can rely on the x-coordinate of the vertex, negative 1. So x equals negative 1 is the axis of symmetry. As far as the y-intercept, what we need is to figure out the function value when x is equal to 0. Scrolling back up indicates to me that if x is equal to 0, then the first term and the second term are both equal to 0, and we end up with simply the negative 6, the constant term. And you can kind of think of this in terms of what you know about y equals mx plus b. The constant at the end there is where you cross the y-axis. The same is going to be true of a quadratic function in this form. Therefore, the y-intercept is going to be 0, negative 6. For the x-intercepts, I know that y is 0. I've rewritten the function for reference here. If y is 0, that means that f of x is 0. And so I'm now solving the equation 0 is equal to negative x squared minus 2x minus 6. We have several ways to solve this. The first thing I'm going to do is I'm going to multiply everything by a negative 1, because we get to do that when we're solving an equation. So 0 is equal to x squared plus 2x plus 6. Notice I'm doing that because I can solve an equation. I cannot take the original function, negative x squared minus 2x minus 6, and change its signs, because that would fundamentally change the function. But as far as solving an equation, I get to do the things that we're allowed to do when solving equations. Now I have a quadratic equation that doesn't factor, and so one of my tools is the quadratic formula. X equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 6 all over 2. And so here we have that x is equal to negative 2 plus or minus the square root of 4 minus 24, that's negative 20, all over 2. Negative 20 inside of a square root would give me a complex solution. Therefore, this graph has no x-intercepts. Well, that's a lot of the information that I was asked for, so let me go ahead and highlight all that, circle it. But we're also supposed to sketch the graph, so ostensibly we should be able to use this information to do so. The vertex, negative 1, negative 5. Let me scroll down just a little more. Negative 1, negative 5 has been plotted there. And then the x-intercept is 0, negative 6. And due to what we know about the axis of symmetry, we know that we also have a point at negative 2, negative 6. And this is probably good enough to sketch the graph of our parabola. Notice again, this particular parabola has a maximum value of negative 5, and that indicates what our range would be. Next, we're given a quadratic function. F of x is equal to 2x squared minus 5x plus 1. We're told to determine whether this one has a maximum or a minimum value, and then find that value and where it occurs. Here's the thing. The value itself is going to be a y value. Where it occurs is going to be an x value. Because f of x equals 2x squared minus 5x plus 1, that leading coefficient is positive, and so this graph would open up. We aren't graphing it, but a parabola with a positive leading coefficient opens up. That being the case, there is a minimum value. So f has a minimum value. Now we got to find out what it is and where it occurs. We actually are going to find out where it occurs first. As a matter of fact, if we look at the vertex hk, the second value, k, the y value, is going to tell us the maximum or the minimum value. The h, which is the x value, is going to tell us where it occurs. In other words, what I need is negative b over 2a to find out where it occurs. To find out what it is, f of negative b over 2a. In other words, we get out of completing the square. So where the value occurs, we're going to compute negative b over 2a. And in this case, a is 2 and b is negative 5. So we need the negative of negative 5 over 2 times 2. So this is going to occur at x equals 5/4. So that's where the minimum value occurs. As for what the minimum value is, we need f of 5/4, and evaluating this function at x equals 5/4 will give us, by substituting and simplifying, negative 2.125, or if you like, negative 17/8, or negative 2 1/8. I really couldn't care less which one you give me. So, to actually answer this question, we're going to say f has a minimum at x equals 5/4. The minimum value is, I'm going to pick the negative 17/8. So once again, where a minimum value occurs is an x question. What the minimum value is a y question. And this parabola had a minimum value because it opened up. Next, if a juggler can toss a ball into the air at a velocity of 64 feet per second from a height of 6 feet, then what is the maximum height reached by the ball? We're given a formula to use. H of t is equal to negative 16t squared plus v sub 0t plus h sub 0, which gives the height h of an object thrown into the air after t seconds. The initial velocity is v sub 0. The initial height is h sub 0. Wow, that's a lot. First off, it's easier for me to say v naught and h naught. So v sub 0 and h sub 0, also known as v naught and h naught. As far as the formula, so we have this quadratic equation, h of t is equal to negative 16t squared, now plus v naught t, but v naught is the initial velocity. The initial velocity was given to be 64 feet per second, so we're going to flesh that out by putting a 64t. And then h naught is the initial height. We're told that the height it's being thrown from is 6 feet. So our function is actually h of t equals negative 16t squared plus 64t plus 6, which has a graph of a parabola, and because the leading coefficient is negative, it would open down. Therefore, it has a maximum value. Here we're asked for what the maximum height is that's reached by the ball. That is going to be a y answer. Therefore, what I need is h of negative b over 2a, the y coordinate of the vertex. Which means I need to start with negative b over 2a. In this case, because we have h of t is negative 16t squared plus 64t plus 6. b is equal to 64. A is equal to negative 16. And let's not forget that we're finding negative b over 2a, so it's negative 64 over 2 times negative 16, which is actually going to be 64 over 32, 2. For context, what this means is t is playing the role of x as the input variable. After 2 seconds, the ball is going to reach its maximum height. But we need the function value, the height at 2 seconds. So h of 2 is going to be 70. Since we were asked for the maximum height, we can say the maximum height is 70 feet. All right. Now we have a company that has found that the revenue in dollars from selling widgets, whatever those are, is a function of the price P that it charges per unit. If the revenue R is given by R of P is equal to negative 1/2 P squared plus 1900 P, what unit price P should be charged to maximize the revenue, and what is the maximum revenue? In this case, what we have is P is playing the role of X, R is playing the role of Y, and so when we are asked what unit price P should be charged to maximize the revenue, noting that this function would have a graph of an upside down parabola, the P is going to be given by negative b over 2a. As far as what is the maximum revenue, that's going to be R evaluated at negative b over 2a. In other words, we need the vertex of this parabola, and then we need to interpret the coordinates correctly. Since a is negative 1/2 and b is 1900, our negative b over 2a is negative 1900 over 2 times negative 1/2. That simplifies to P is 1900. Now remember what P was. P is a unit price. Therefore, this company should charge $1,900. To figure out the maximum revenue, we need the revenue. If the company charges $1,900, so R of 1900, which is going to turn out to be, after substituting and evaluating, R of 1900, $1,805,000. So I can finish my sentence here. Company should charge $1,900 for a maximum revenue of $1,805,000. Now we've got a word problem, and it's kind of a wordy one. A farmer with 8,000 meters of fencing wants to enclose a rectangular plot, then divide it into 2 plots with a fence parallel to one of the sides. I'm going to stop reading. I'm going to start drawing. What I'm going to do is I'm going to draw a rectangle, and we want to divide this up into 2 plots, so I'm going to draw a vertical line to match the width of the rectangle and set it up so we have 2 rectangles side by side. 8,000 meters of fencing needs to account for the 3 vertical segments as well as the 2 longer horizontal segments. I'm assuming longer. It may not turn out to be. Okay, it will be, but you know, there we go. What we need to do is label stuff. I'm going to identify the 3 vertical segments as having a length of x. So x meters for each of those 3. And then if we've got 8,000 meters of fencing, and we've just accounted for x 3 times, then 8,000 minus 3x is the amount of fencing that we have to take care of the 2 longer horizontal sides. Since there are 2 of those, we take that 8,000 minus 3x, cut it in half, and we have 8,000 minus 3x over 2 meters for the dimension, the longer dimension. Now back to our problem. What's the largest area that can be enclosed, and what are the lengths of the sides of each part of the enclosed area? The largest area that can be enclosed, I read that as maximum. I bet this is going to be quadratic. Let's find an expression that gives the area of this enclosure. Area is length times width. Length 8,000 minus 3x over 2. Width, x meters. So the area doesn't take into account the vertical segment that divides the two pens. The area is just the total enclosed area. This area is now, if I simplify, 4,000 minus 3 halves x, that quantity times x. And so the area as a function of x is equal to 4,000 x minus 3 halves x squared. As suspected, this is a quadratic. The leading coefficient is negative. Well, it's not leading the way I've written it, but the quadratic coefficient is negative, which means this is, if we were to graph it, a parabola that opens down and therefore has a maximum. If we were to consider what would be the axes labels, x is the horizontal axis. That's the width, as I've drawn this rectangle. And then the vertical axis, is, which is taking the place of y, is the area. Therefore, if I can find the vertex and look at its y-coordinate, I will have the maximum area for this structure. Recall there's a formula. The x-coordinate of the vertex is negative b over 2a. So we need that negative b over 2a to know the lengths of the sides, at least the vertical sides. We'll figure out the horizontal by evaluating the expression once we find out what x is. And then we need the function evaluated at negative b over 2a to find out what the actual area is. Note that b is the coefficient of the linear term, and so for our area expression, b is 4,000. A, being the coefficient of the quadratic term, is negative 3 halves. So negative b over 2a is negative 4,000 over 2 times negative 3 halves. That turns out to be 4,000 over 3, which is kind of not very friendly, but oh well. The value we just got is the x value for the 3 vertical segments. We can use this to figure out the length, having gotten the width. 8,000 minus 3 times 4,000 over 3, all over 2, turns out to be 2,000. I'm actually going to give part of my answer using that picture. So I'm going to redraw the rectangular pen with that line dividing the rectangle. And 4,000 over 3 I'm going to call 1,333 and a third meters. And because this is a rectangle, it's good enough to label one of those 3 verticals. And then for the width, 2,000 meters. And I'm going to call that good enough for the dimensions that maximize the area. As far as the maximum area, we could either multiply this 2,000 by 1,333 and a third, or we could evaluate A at 4,000 over 3. I leave the choice to you, but for verification, we're going to say the maximum enclosed area is 2,666,666 and 2/3 square meters. Last but not least, the graph of a quadratic function f of x equals ax squared plus bx plus c has a vertex at 1, 4 and passes through the point -1, -8. Find a, b, and c. In other words, we can find the equation of a parabola if we just have its vertex and a point that's on the graph. For this, we're going to go back to the expression that defines the function f of x equals a times the quantity of x minus h squared plus k. Wouldn't want to leave without seeing this. We are told that there is a vertex at 1, 4, which means that hk is equal to 1, 4. I can actually start to flesh out this function. F of x then is equal to a times x minus 1, the quantity squared, plus 4. So this is like the process that we've seen a couple of times in reverse. Now we're told that this graph passes through the point -1, -8, which means when x is -1, y is -8. So f of x is y. We're going to put a -8 there. And we're going to say that that is equal to a times the quantity of x is -1. H was 1, so -1 minus 1, quantity squared plus 4. Notice that we have now an equation with only one unknown, and that is a. So we're first going to simplify and then isolate a. I have -8 is equal to a times -2 squared plus 4. Since I'm solving for a, what I'd like to do is subtract 4 from both sides. And at the same time, I'm going to go ahead and simplify -2 squared. So I get -12 is equal to 4a, which indicates to me that a is -3. Now I have that f of x is equal to -3 times the quantity of x minus 1 squared plus 4, which is almost good enough, but if we scroll back up, we were asked for a, b, and c. So we're just going to put this into what's called standard form by foiling. So I have f of x is equal to -3 times the quantity of x squared minus 2x plus 1 plus 4, which is going to simplify. F of x is equal to -3x squared plus 6x minus 3 plus 4. Finally, we can say f of x is equal to -3x squared plus 6x plus 1, giving us that a is equal to -3, b is equal to 6, and c is equal to 1.